Good afternoon, ladies and gentlemen. I will briefly inform you about what we are doing in the field of computational linguistics at the Institute of Mathematics and Computer Science at the University of Latvia. And I'll mainly focus on recent and ongoing research and development, so part of which is not yet taken into account into the previously presented white paper. So I'm optimistic that in the next survey, the position of Latvian will be better in these figures. So at our institute, we have been working in this area already for about 20 years. And the main research directions are traditionally it's machine translation, and also speech processing, mostly text-to-speech synthesizing, also development of language resources, grammatical and tools and grammars for morphological and syntactic analysis. And also recently, we are more and more focusing on semantic analysis, and we are also entering a new field that's called controlled natural language. Well, it's not a new field in general, but at least for us. And also mainly we are focusing on Latvian. We are also recently more and more entering into the multilingual settings, especially in the field of semantic analysis and these controlled languages support Latvian in multilingual frameworks. And I'll start with language resources, as Kadri Vidra already emphasized that this is the first thing to talk about and think about to build further tools on top of these resources. And over the time, we have gathered various special corpora of different sizes. But I would like to point out not the largest corpora that we have gathered, but actually some small pilot projects, pilot resources that have been recently created and are constantly improved and enlarged. So first of all, there is thanks to the funding from Latvian Language Agency, there has been created a tiny but balanced corpus of modern Latvian. Of course, it's much too small for lexicography needs, but it's already useful in research in syntactic analysis and syntactic semantics. And there are also been developed several morphologically annotated corpora, but again, based on a subset of this balanced corpus, we have recently created a balanced morphologically annotated corpus that has been verified by two linguists, and using also statistics and concordancies from this balanced corpus, we are currently creating a valency dictionary for Latvian, and currently we have covered about 160 verbs, which means that we have annotated more than 20,000 concordance lines, both annotating the syntactic and semantic valence. And there is also a tree bank project started a few years ago, and currently, well, we have less than 2,000 sentences, but it's again already sufficient to start some experiments in statistical parsing. So a more or less practical tools that have been developed on top of these corpora are a few taggers. First of all, morphological tagger that has been trained on this balanced 30,000 token corpus. And the current accuracy is 92%. Of course, for practical needs, it should be over 95, but because of this very modest size of our training corpus, there is a clear space for improvement. And also, in a project for National Library of Latvia, we have first created a corpus that has been where named entities have been annotated, and the size is about 80,000 tokens, and the precision what we got from this corpus is already 85%. And another important field that heavily uses different text corpora, especially annotated ones, is machine translation. And initially, of course, in 1990s, this research was primarily in rule-based systems, and of course later it moved to statistical translation. And our planned future work is to start experiment with hybrid machine translation, and the primary focus in our case is on English-Latvian translation, but also on Latvian-English. And the recent efforts have been on evaluation of various factored models, factored language models to use in statistical translation, starting with morphological annotations. Also, we have recently started to use syntactic annotations, and future plans are also to use frame semantic annotations, but of course this causes the need of annotated corpora and statistical parsers that are well supported for this English side, but not yet that well for Latvian. And also I'd like to point out a non-traditional machine translation area that we have also recently have started working on, and it's there are two very similar problems that can be addressed by the same techniques. And first of all, it's normalization of historical Latvian texts, which means that which involves both correction of OCR mistakes and transliteration to the modern orthography. So to some extent this can be seen as translation from historical to modern Latvian. And on the other side there is normalization of user-generated online content, and there has been growing interest from other disciplines, for instance social sciences, to do some text analytic tasks on online content. So this is another interesting area that we are exploring. About this field of controlled languages. So here the settings is that controlled language is a syntactically and semantically restricted subset of natural language, and it's therefore application and domain-specific language, and so it can be used for specific tasks, not for general purpose tasks. And there are several practical applications that use controlled languages. one of them at the very restricted level are, for instance, applications that deal with translation between controlled natural language and the formal language, for instance, to some formal logic used for modeling tasks, and some less formal applications are, again, application and domain-specific machine translation tasks, dialogue systems, for instance, to create grammars for use in call centers or applications like already mentioned Siri, and so on. And the challenge here is to bridge the gap between controlled languages and natural languages, and this is an open question not only for Latvian but in general in this field. And our proposal is to address this problem by we are frame semantics, namely FrameNet, and so this is a direction where we are currently actively working on. And to facilitate creation of various controlled languages, we have created the Latvian resource grammar in the grammatical framework, so-called. It's a formalism and a toolbox for developing multilingual controlled languages. So, why resource grammar? It's because there's a separation between general purpose resource grammars and the application-specific controlled languages that are built on top of these resource grammars in a rapid way. So all the low-level language details are covered once in a resource grammar, and we have done this for Latvian. And so now we are experimenting with some applications on top of this resource grammar. And previously we have created also a hybrid dependency-based partial chunker. Why partial? Because it doesn't include any constraints on syntactic or semantic valencies. It only ensures this syntactic agreement. So this grammar is highly ambiguous, and we are now, thanks to these pilot corpuses and pilot lexical resources that we are creating, we are investigating how to include statistics into this rule-based parser. We are also starting first steps to experiment with data-driven parsing, and well, the future aim of all this is to support semantic parsing for information extraction needs and like that. And also a stable and constant research group at our institute has been dealing with speech processing, and particularly with text-to-speech synthesizer. And so we have collected a default database and we have specified some concatenation rules to support such text-to-speech system. But there are several necessary improvements that can be supported only by a speech corpus. So speech corpus is another corpus that we are slowly working on. So currently we have a raw data that has been orthographically transcribed and aligned to the audio data, and the future task, the planned task for next couple of next years is to create a prototype of a speech corpus that would include also phonetic transcription and all the necessary information for to extract statistics on stresses, pauses, phoneme combinations, and etc. So, thank you.